welcome back to my channel. Today we are going to solve another Leetcode problem, number 676, implement magic dictionary. So basically this question is let us to design a data structure can search for a word. So for example, we are going to use the magic dictionary. So for this one, this is for the initialization of the magic dictionary. So inside we will have like two words. So one is hello and another is Leetcode. And then we are going to search one by one. So the search will return a boolean, true or false. So for example, hello, because there is a hello inside, we didn't change any one of the characters, so we're gonna return a false. But for the second one, in the second place, there is an H. So this H can be changed to character E, and so we can return a true because there's only one character needed to change. And for the third one, hell, yeah, of course, there's no word inside the ring to have a length of 4, so it is not possible. And for the last one, leetcoded, of course it is longer. We should return false. I'm going to use a try to solve this problem. Basically, the first method I used is the brute force of try. I did it and it passed, but it is very slow. But I'm going to talk about the brute force solution first, and then try to optimize, use the DFS to search it to optimize the time complexity. I'm going to first explain the brute force method and then try to analyze the time complexity, and then go to the method 2 to optimize it. So for this kind of a problem, we are giving some kind of structures, like we are giving a magic dictionary and we are giving an init. We also give something like a build a dict, and we also give something like a search. Yeah. So we are going to use the existing data API, and we are also going to add some of our other templates. So for the try, as I said before, this try can use some kind of a template to implement the API of try. So we are going to have a try node. So inside the try node, there will be self.children. This means it has its children is a dictionary. So there's another variable. It is the add of a word. Basically, this means if there's a word, for example, hello, if this O is the add of a word, if it is the add of a word, we're gonna return a true. If it is not, it is a return false. So this is the definition of the try node. So from the beginning, it is false, and inside of the children, it is an empty dictionary. Yeah, and then we are going to use this magic dictionary. Here, I am not going to use a try because I will imagine this as a try node. So inside, I will define as before, the self.root as the try node. And this is similar like basically the template of try. We are going to have an insert API. So this insert API just needed to check the character inside the word. If it is not in the children, inside the root.children, if there's no such character, we are going to create a try node. Yeah, and we are going to use this letter C to create a try node. Yeah, otherwise, if we didn't have this kind of line, we still going to go forward to this current.children, to this character. But at the end of the word, we are going to return a true. So this is just the basic operations of the insert for a try. And here for build the dict. So for build the dict, here it should be very simple. We just to find its word inside of the dictionary and insert the word into our try. After here, we've already built the try. So the last step is going to search the word. So here, this search word is basically also the basic structure of the try. This search word is just to find a word inside of the try. If there is a word, we're gonna return if there is a word inside, we're gonna return true. Otherwise, we're gonna return false. So here, basically, this is similar like the insert. But only difference if this character is not inside, we're gonna return a false immediately. Otherwise, we go forward to that character and put it to another dictionary. Yeah, we just go forward. So the current.current.children.c. We just go forward to check another character. But at the end, we're gonna return current.add of a word. That is the only difference. So because we are not sure if this add of a word is true or false, so here the search word will just return the current.add of a word. It may be a true or maybe a false, but here can return immediately if we didn't find a character. Yeah, for this word. If there's a inside a character we didn't find its children, we can return the false immediately. Otherwise, we're gonna return the add of this word. Yeah, so if it is true, it means we find the word. So for the first one, this is my code basically. And before that, everything is a template. If we did a lot of try and Leetcode problems or other algorithms about trying, so we know that this is basically the template. We didn't needed to take so much time about it because everything is a template. We can just use it. And then for here, this is my first method. I'm going to use a brute force. So for the brute force, because I'm going to find a word, for example, so here, for example, I have this word or the first word, but yeah, for example, this one, it's LLO, hello, but in the second, it is AIDS, yeah. For this one, what I'm going to do is I'm going to use, for each index inside the word, I'm going to just change it. For example, for the first one, for the first letter, this is 8. I'm going to change it to 25 characters except 8. So we know there are 26 lowercase letter characters. So we are going to change it to other 25 characters. Yeah. So this is my code. So for C, for this character inside the all lowercase characters. Yeah. If this character C is not equal to my index search word I, if the character is not equal to 8, it means the other 25 characters. Yeah. And then I'm going to have a new word. So this new word is just in Python, we can just use this syntax, just search word to I and plus this C and search word I plus 1 and to the left. Yeah, so this is the new word. So this means I'm going to build a lot of new word and then I'm going to search this word. If I can find this word, I'm going to return true. If I didn't find all the combinations, I'm going to return a false. Let me submit it to check how slow this algorithm is, and then I'll analyze the time complexity. Yeah, as we can see, it works, but it's really slow. It's more than 3 seconds and about 5% of all submissions. We know that for the try method, it is itself very slow, but for our algorithm, it is totally brute force. It's even slow. So let me analyze the time complexity. Yeah, so basically for building the try, it didn't take so much time. So for this build, the dict, so that is only the length of the dictionary, and insert the word, it's the length of the word. Yeah, maybe it is m times n. M is the length of dictionary, n is the length of word, but it didn't take so much time, so it doesn't matter. But what we are going to analyze is the search. So the search takes time. So from here, we know that there are 100 operations of search. Yeah, maybe the build dictionary is only one operation. I think it's enough. We don't need to build it one and another because there is no change of the magic dictionary. Yeah, so there is only one time. It is still okay. But for the search, it may be many times. But here it is said 100 calls maximum. Yeah, so first of all we have 100. It is Let me put it here for the time complexity. So the time complexity will be here. So first we have 100. It is how many calls. And then we are going to have 25 characters. Yeah, because for each of the things, there are not 26, only 25, because if it is itself, we do not need to consider. Yeah, and after that, if we think that how many positions, it is the less of the word. Yeah, and the less of the word is 100, so it needs to times 100. Yeah, and then this is not the end. After we change the one word, we need to combine if this word equals to this word. How we are going to do? We are going to search inside the trie. So if the length is 100, we're still going to loop through to the trie. It's going to have another 100. Yeah. So for this one, it equals to 2.5 to the power times 10 to the power of 7. Yeah. So if this 100 is like n, this is 25 is m. So it is m times n to the power of 3. Yeah. M times n to the power of 3. So this is the brute force method. But this is still okay because 2.5 times 10 to the power of 7 is still okay. But sometimes you cannot pass in Leetcode because this is just like a limit. Yeah, if this is bigger enough, you cannot pass it. So my second solution is to optimize this. It's totally the same, but just I'm going to optimize use another method because I'm not going to use brute force to search all the combinations of the word. Why not I search from the beginning, not to have all combinations, just search it from the beginning to check if I can find it. If I cannot find it, I will return false. If I can find it, I will return true. Now let's go to the second method. Yeah. So the second method, I'm going to define a find word function. And I'm not going to use this one, search. Yeah, because that is not necessary. I'm not going to use this brute force. And here, I'm not going to use here the brute force areas. Yeah, I'm just going to use to call the function. Yeah, let me explain this function find word. So the first position is the count. So the second position is the self.root. So this is also similar. So the third one is the search word we are giving. Yeah. I'm just going to check use DFS to search if it works. Yeah. So now let's go to the function. So here is the condition. Yeah, I'm not going to explain this one first, but I'm going to explain from here. So for here, for k inside all the root.children.case, it means inside of the dictionary, we need to find the first character or not. For example, the first character maybe this one is L. Yeah. For example, this one maybe 8. Yeah, we are going to find if this 8 is inside my trie. Of course, when we are built with that one, with hello and Leetcode, the 8 is inside. Yeah. So I'm going to execute this line. So k is here. So k is the word. So for k is inside all my case. If k equals to my first letter of the word, yeah, so this is the word. So if it equals to the first letter of the word, I'm just going to check if I can find it or not. So I will call the self.find word. Here is still the code because I didn't decrease. So here is still the root.children, but here the root.children should be the k because I'm going to find the next one. So what is the next one? It is the k, the word 0. Yeah, so I'm going to find the root.children k. But the word should also be decreased by 1. So the word should be sliced to word 1. Yeah, before it is word, so I need to delete the first character of the word. So this is one condition. But there is also another condition. What if the k didn't equal to the word 0? Yeah. So for example, here I used the word 0 because here I used the slice just to take out that word. So every time I can use k equals to word 0. Yeah. And if we didn't have that condition, it means here for the second one, for this 8, if we didn't find it inside of the trie, what we're going to do is we're still going to check the count because we have an opportunity to make one mistake we didn't find. So and if the count equals to 1, if the count from, because I'm going to call the function from 1, yeah. So if the count equals to this one here, yeah, I'm going to decrease this one by 1. So 1 minus 1 is 0. So I'm going to check if I can still find it or not. So this one becomes 0 because this is 1 minus 1. And for the root dot children, it's still the same. Even I didn't find, but the count is 1, I can still let it pass to the next one. So the root dot children dot k still works. So for each k inside, any k inside. For example, here the second, yeah, the first one maybe 8, the second one maybe e. So for any k inside, for this e letter inside, I can still let it go through. Yeah. So here I still let it go through. I'm going to check this branch to check if it works or not. If it works, I'm going to return true. Yeah. So here is the main part of the function because I'm going to check the final result. So how to check the final result? So if there's nothing in word, so if this word is empty, so it means it goes to the end. Yeah, because every time I'm going to slice one word, delete one character. Every time I'm going to delete one character. So when it becomes empty, so if it is not word, the word becomes empty. I'm going to check if the count equals to 0, and it's also the end of the word. So it means here, every time if it goes to this branch, the count will minus 1. If the count is 1, it's still not possible. Maybe it's for example here, maybe hello, it should return false. So I'm only going to check if this count equal to 0, and also it's the end of the word. The end of the word is true. For example, this end of the word is O. It goes to O, it's end of the word. So I'm going to return true. Otherwise, for any other conditions, I'm going to return false. So this is the difficult part. This is much harder than the brute force solution because for DFS, we are going to design the algorithm to find the conditions to return true or false, and inside we are going to loop one by one. I think this one is easy to think, but this one, yeah, may sometimes forget. Yeah. Now let me submit it to check if it really works here. Yeah, as you can see, this is much faster. It's more than like 50%. Let me analyze the time complexity of method 2. So for the method 2, basically, we are going to use a search directly. Yeah, and for that search, let me check. Yeah, so for the trie, we know that there are maximum 26 characters. Yeah, it cannot be more than 26 for the English lowercase letters. Yeah, so that is definitely the case. And also for each of the trie, so the maximum length of the word is 100. So it means the depth of the trie, the maximum depth of the trie is also 100. That is for sure. Yeah. And how many calls? We are told there are maximum 100 calls. Let me go to here. Yeah, we are maximum have 100 calls, so we need to time this 100. So in this way, the time complexity becomes 2.6 times 10 to the power of 5. Yeah, it basically reduced 100 times. Yeah. So as we know, this method is much faster. It's basically like 26 times n to the power of 2. This n equals to 100. Yeah, it's the length of the word. So when we build the trie, it's the depth of the trie. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problem like that. Bye.